Across Ontario, on countless demolition sites, there's a huge, growing mountain of a problem: wood waste. But what if we could turn that problem into an incredibly valuable resource? What if we could use it to power the province's green economy? Well, today we're going to break down a really revolutionary system that does exactly that, transforming this massive waste stream into clean fuel for our bio-future. And this slide right here perfectly illustrates the core challenge. On one side, you've got the reality of a construction site, right? It's just a chaotic mix of wood, often contaminated with paint, chemicals, plastics, you name it. It's messy, it's unpredictable, and basically unusable as is. Then, on the other side, you have the dream, this perfectly pure biocarbon, a clean, reliable feedstock that we need for things like green steel or renewable natural gas. That gap between the mess and the dream, that's the quality mismatch, and it's the reason most of this wood has just gone straight to a landfill. Well, until now. You see, this isn't just a waste problem, it's a huge economic opportunity that we've been missing. Ontario's own Forest Biomass Action Plan makes it crystal clear. We have to find better ways to use all this underutilized wood. Think about it. With pulp mills closing, some sawmills are literally drowning in wood chips they have nowhere to send. There's this massive supply of biomass just sitting there, but the bioeconomy hasn't been able to tap into it because of that nagging quality gap. So what's the solution? It's called the 95-wood Digital Refinery. Now, the best way to think of it is as a sentient bridge. It's not a physical building with smokestacks. Instead, it's a smart system of advanced AI and mobile tech that's designed to live right there on the messy front lines of waste collection. Its entire purpose, its whole mission, is to sort and verify the quality of wood waste the second it's picked up, guaranteeing it's clean enough for the bioeconomy. And what's so cool about this is the philosophy baked into it. The whole system is designed with this kind of Hamilton grit meets Silicon Valley vibe. It totally gets the tough, dirty, physical reality of demolition bins and waste trucks, but it pairs that with a kind of sleek, clean, and powerful data processing you'd expect from a top tech company. And that's not just about looks. It's about building a tool that's tough enough for the job site, but smart enough for a laboratory. So, how does this thing actually work? Okay, let's dive into the core technology. It all starts at what's called the on-site compliance gate. This happens right at the construction site, and it's that first moment of contact. It's where the digital world and the physical world collide. The key here, and this is absolutely critical, is speed. The system is the first line of defense. The moment a driver points their device at a bin full of wood, the on-device AI runs a super fast triage. It's a simple yes or no question. Is this load potentially clean, or is it contaminated? And it makes that call, get this, in under 2 seconds. And this is the hardware that makes that instant analysis possible. Now, forget about some generic app. This is a custom-built, specialized system running on a Google Pixel 10 Pro. It's packed with a powerful Tensor G5 chip, a next-gen Edge TPU, all of which means it can process everything right there, on the device instantly. But even more important is the security. It's built right into the hardware with the Titan M2 chip, making every bit of data it captures verifiable and totally tamper-proof. It's basically a pocket-sized continuous inference server. But here's the system's absolute core principle, and it's a brilliant one. Your camera sees color, not chemistry. The Digital Refinery works on a guilty until proven innocent basis. That 2-second AI triage, it's just an estimate, a really, really good one, but still an estimate. The system fundamentally distrusts the phone's camera because it knows that just looking at a piece of wood can't tell you if it's full of chemical contaminants. The final, real verdict has to come later. So let's walk through what the driver actually does on their phone. It's called the WIPE protocol. First, at the compliance gate, they point their phone, and a live AI overlay appears on the screen, analyzing the wood and flagging potential risks, like pressure-treated lumber. Then the driver does a hold to seal. They just press and hold the screen for 2 seconds. They get this satisfying little buzz, like using an old-fashioned wax seal, and in that single moment, it locks in the precise GPS coordinates and cryptographically seals the digital chain of custody. It's that simple, super secure, and completely tamper-proof. All right, so the data has been captured and sealed right there at the edge, on the demolition site. Now let's follow that tiny packet of data as it travels from the truck all the way to the central compliance engine in the cloud. Here's the entire data journey, start to finish. It all begins at the edge, with that Pixel phone capturing the initial info. That data then shoots up to the cloud, where the compliance engine instantly cross-references it with Ontario's waste regulations, specifically OREG 347, and generates a certificate. Next, the physical truckload of wood arrives at the hub for the real ground truth verification. And finally, the output is a single, clean document that's ready for the border, whether that's a regulatory inspection or an actual crossing into the US. And this is the hub. This is where that whole guilty until proven innocent idea really pays off. The truck rolls in, and these advanced sensors, we're talking X-ray fluorescence and near-infrared, scan the load. Now, this isn't an estimate anymore. This is pure science. These instruments are measuring the actual atomic composition of the wood, delivering the final, undeniable verdict on its purity. And just how rigorous is this check? Well, the system is looking for very specific contaminants that are defined by government regulations. You can see right here in the table. It's detecting things like arsenic and chromium from treated wood, or lead from old paint. Each one is measured against a precise legal limit. This isn't just about quality anymore. This is about absolute regulatory compliance and public safety. So we have this incredible, robust process, right? From an AI estimate in the field to atomic level verification at a hub. But what does it all lead to? What's the final output? What is that one single document that ties this all together and proves you can trust it? I mean, this is the key that unlocks the value of the entire system. It's the one thing that proves to a regulator, a border agent, or a high-tech biorefinery that this truckload of wood is exactly what it claims to be. And the answer is a simple, secure, cryptographically verified, and yes, fax-ready PDF. Now, fax-ready might sound a little low-tech, but the design is pure genius. It's formatted for the regulator, not just for the customer. It's a universal document that any agency can easily understand and process, making sure there are absolutely no barriers to compliance. But inside that simple-looking PDF is an absolute fortress of security. This is the 9-point certificate of origin. And you can think of each one of these points as another lock on a vault door. You've got the hardware root of trust from the Titan M2 chip, which proves exactly which device took the reading. An atomic clock signature for a tamper-proof timestamp. The kernel hash verifies the OS integrity. The GPS coordinates are locked in, and it's all bound together with a final cryptographic hash. You cannot fake this. This is a digital handshake that is literally backed by silicon. Out in the real world, this certificate has a pretty powerful name, the USMCA Shield. You see, for cross-border trade, proving that a product was wholly obtained or produced within North America is a huge deal. Well, this document provides that hardware-attested, undeniable proof of origin and composition, satisfying the intense scrutiny of border officers and complex trade regulations. This shield doesn't just clear a path across the border, it clears the way for an entire new industry. So let's zoom back out for a second. Because this whole thing isn't just about a clever piece of tech or a secure PDF. This system is truly a foundational piece for building Ontario's entire biofuture. And here's the main takeaway. By finally solving that fundamental quality gap, the digital refinery acts as the missing link we've always needed. It takes a chaotic, low-value waste stream and reliably transforms it into a high-quality feedstock. This single process unlocks the immense hidden value in all that waste, creating the consistent supply chain needed to power a truly circular bioeconomy. And the impact could be massive. We're talking about diverting millions of tons of wood from landfills and turning what was a disposal cost into a new multi-billion-dollar green industry for Ontario. And that leaves us with a really fascinating thought to end on. This whole system of Edge AI, hardware security, and ground truth verification was built for wood. But if we can create a sentient bridge to digitally refine wood waste, what's next? What other complex, messy waste streams out there are just waiting for a similar system to come along, unlock their hidden value, and turn our biggest problems into our greatest resources?